Hey guys, welcome back to my YouTube channel. Today I wanted to discuss reduction of alkynes, and I sound like this because I have been sick for the past week, and so yeah, I'm just congested. But yeah, in today's video I wanted to discuss the reduction of alkynes. As you might recall from alkene reactions, we used H2 and PD with the catalyst. And that just turned the alkene into an alkane, right? In reduction of alkynes, there's 3 reductions we can do, right? So the first one is a total reduction, and this is using H2 and PD/C, right? So that's a total reduction, going from an alkyne to an alkane. So right. And so the second type of reduction is partial reduction, right? And actually, there's 2 types of reductions. There's total and partial, right? But partial actually falls into 2 types of partials, right? There's the cis and the trans, right? And in these, we're not going from an alkyne to an alkane. We're going from an alkyne to an alkene. Alkyne to alkene. And yeah, so as you can see in this first one, we go to a cis alkene, and then the second one we go to a trans alkene, right? And we get this cis alkene using what was it again? It was H2 and a Lindlar's catalyst. And the Lindlar's catalyst is made of a bunch of things. It includes PD, but more than likely on your exams and quizzes, you'll see it written as Lindlar's catalyst, right? Or just Lindlar's. To get the trans alkene, we use Na and NH3 in liquid form, so liquid ammonium. And yeah, so actually, let me get a sip of water. So I'm going to do a couple of example problems. Okay, cool. So first example, we're going to do total reduction. And we're going to do this using we're going to use an internal alkyne, right? So this is our starting reactant, starting alkyne, right? And we're going to use H2 with PD/C, and that's going to result in a total reduction, right? So we're going to count the carbons. 1, 2, 3, 4. Okay, and we're going to draw our line diagram. So that's 4. 1, 2, 3, 4. And we can see here that the triple bond lies in between 2 and 3. And so, so basically that does not matter because it's a total reduction. So this would actually be your final product. As you can see here, we went from an alkyne to a alkane, right? And so these are just carbon to carbon single bonds with nothing else. There's no alkene, no double bond, just an alkene. And you just want to make sure while you're doing these that you're matching the amount of carbons correctly. So yeah, don't mess that up. So that's why I like to count the carbons. So in the second example, we're going to get let's do a cis alkene. Okay, cool. So this is going to be our starting material, right? And as the reagents, like I said earlier, we're going to be using H2 and Lindlar's catalyst. All right, cool. So you just want to count the carbons. And as you can see here, I have 4 carbons on the side as well. Right? And it's the cis alkene, which is why I drew it like this. Right? And cis means that the substituents on each side of the double bond that we have are facing in the same direction. So this is the cis alkene. Cool. Yeah, so last example, we're going to get a trans alkene as the product. Right, same starting material. And these starting materials are internal alkynes. And so this time we're going to be using Na and liquid ammonium. Right, so we count our carbons. It's 4 carbons, like we decided earlier, or that we counted earlier. And we're going to draw our line diagram, or our line drawing of carbons. Right, so that's 4. And as you can see here, on carbons 2 and 3, right, there's the triple bond, correct? So on carbons 2 and 3 here, I'm going to draw the double bond, right? So double bond will go there. And as you can see here on this alkene, right, on both sides of the double bond, I have 2 substituents that are going in opposite directions. And if they're in opposite directions, it's the trans version, right? So this product that we have here is the trans alkene. And yeah, so that was alkyne reduction. You have your total reduction, partial reduction. Partial reduction can fall under cis or trans. And yeah, thanks for watching, guys. I will see you guys next video.